All right, welcome back, everybody. This section is going to be a little bit shorter than the other section because we're already familiar with all the vocabulary. We're familiar what degrees of freedom is. We're familiar with using the chart. So it's more so just translating over everything that we learned into a hypothesis test, which the actual setup of the hypothesis test is exactly the same as we learned before. We're just doing this in the context of a t-distribution instead. When the population standard deviation is unknown. Okay. So here we're going to test the population mean when the population standard deviation is unknown using the student's t-distribution. This was actually something that we learned in the previous class. So that's going to be the second point here. And then there's also this idea of comparing the critical regions for the p-value method. Not sure if we're going to actually get into that too much in this section, but we will probably get into that in a different time. Just sort of doing the preview here. Okay, yeah. So don't worry too much about this critical region area part as well either. We're really just focusing on that middle bullet point here. Okay, just a refresher here, we are working with the t variable still, where you're going to be finding the difference between the sample mean and the population mean, all divided by the sample standard deviation divided by the square root of the sample size. And of course, we need to use that degrees of freedom equation, which is degrees of freedom is equal to n minus 1. Okay, just to give us a refresher on the hypothesis testings here, the first thing that we want to do is state the null and alternative hypotheses. You're going to want to find the sample statistic test to calculate the t-value, which is going to be this equation here basically is what it's telling us on number 2. Number 3, you're going to want to use this t-distribution table to estimate the p-value and correspond it to the correct test, which is the one-tailed or the two-tailed. Then you're going to conclude the test and interpret the conclusion. Okay, so step 3, you're going to have to use that degrees of freedom equation. And then steps 4 and 5, nothing new. It's the stuff that we learned from the previous class. But before we move on, let's do a knowledge check for the hypothesis test real quick. What are the only 2 accurate conclusions that you can make, for a hypothesis test? I'm going to have y'all pause, think about it for a second, and come back. The 2 accurate conclusions that you can make for a hypothesis test are reject the null hypothesis and fail to reject the null hypothesis. Okay, so you're only making conclusions about the null hypothesis and you're only doing some kind of rejection level. You're never accepting and you're never going to be talking about the alternative for your hypothesis tests. Okay, now that we had that refresher, let's go in and actually do one of these problems. A local hospital claims that the average weight of newborns is 7 pounds. We randomly sampled 29 newborns and found the average weight to be 7.16 pounds with a sample standard deviation of 0.6 pounds. We suspect that the average weight is greater than what was originally claimed. Assume an alpha of 0.05 or a level of significance of 0.05. Okay, well, that was a lot. Let's figure out what we got to do first. Okay, we got to state the null and alternative hypotheses. Okay, so state null and alternative hypotheses. Okay. So when writing out the null and alternative hypotheses, we first want to determine what kind of problem we're working with here. Are we working with an average or a proportion? Here we're working with something about average weights. So we're going to be working with a proportion. Not a proportion. We're going to be working with a mean. My bad. So we're going to write out the symbols for the population mean because we're making hypotheses based off of the population here on both here. Okay, what is that claim for the population mean? Again, whenever we see that claim statement, everything that's in that statement is going to be related to the population. That is going to be an average weight of 7 pounds. So the null hypothesis, or what is claimed originally, is that it is equal to 7 pounds. And now we got to figure out what kind of test are we doing. Are we doing a left-tailed test, a right-tailed test, or a two-tailed test? Okay, or in this case, we're only looking at one-tailed versus two-tailed. Okay, so here, we suspect that the average weight is greater than what was originally claimed. Greater than is going to be looking to the area to the right. So we're going to be looking at mu being greater than 7. Okay? Visually, that's going to look like something as such. Okay? So we are working with a one-tailed test here. Okay? Because we only have one tail shaded. Perfect. What's the next step that it's saying for us to do? We want to use the sample statistic test to calculate the t-value, okay? So here we're going to calculate our t-value, which is going to be our sample mean minus our population mean, divided by the sample standard deviation divided by this square root of the sample size. I'm going to move this over just a little bit because you know I like listing out the variables to the left here. Mean, population, sample, standard deviation, and sample size. Okay, so let's see. We already know what the population mean is because we just had to find that for the null hypothesis and the alternative hypothesis, 7 pounds. Okay. Here we randomly sample 29 newborns. That's our sample size. And we found the average weight of that sample to be 7.16 pounds. Okay, and the sample standard deviation is 0.6 pounds. Okay, so now that we have all the variables written out, we can actually use this equation and find our answer. So, or find our t-value. So t is equivalent to 7.16 minus 7 divided by 0.60 divided by the square root of 29. For these problems, I like to look at a top-bottom approach and solve the numerator and then the denominator. 7.16 minus 7 is 0.16. Let's actually write out what I did there. And then the bottom is 0.60 divided by the square root of 29. The square root of 29 is about 5.385164. So we're going to write 6. Okay. 0.60 divided by 5.38516 is going to give us 0.111417, so we're going to put 2 there. Okay. Putting these two numbers together, we have a t-value that's equal to 0.16 divided by 0.11142. 0.16 divided by 0.11142 is going to give us a t-value of 1.44. Okay. Perfect. The next step here is to use the student's t-distribution table to find and estimate the p-value corresponding to the correct test. Okay. So here is going to be where we deviate a little bit. So we have a t-value of 1.44, okay? And we're working with a sample size of 29. So we have the degrees of freedom is n minus 1, which gives us 28, okay? We want a level of significance at 0.05. Our confidence level is going to be 0.95 then. Okay. But if we're looking at 0.28, or 28 is our degrees of freedom, we now want to look at the values inside the chart because that's going to be our critical t-value. So or our t-values. That's 1.44. Okay. And this is where these two top areas come into play here. So that's going to be our p-values that we use for our chart. So if we look at 1.44, we want to try to find where that's located in this chart. 1.44 is going to be in between these two numbers, 1.313 and 1.48. It's greater than 1.313, and it's less than 1.408. Okay. That means our number of interest is going to be here, and our p-value is going to be somewhere in between 0.075 and 0.100. So the only downside with using this kind of chart is that you're not going to have a specific number for your p-value. You're going to have to make some kind of estimate. So our p-value is between 0.075 and 0.100. Okay. And we want to compare that to our level of significance of 0.05. Any number in between this range is always going to be greater than the level of significance. Okay, so this is actually getting into parts 3 and 4, which I think the fourth one was concluding the test. So since the p-value is high, you're going to fail to reject the null hypothesis. Okay, so this is a little bit different than like what we did before, because we're making an estimate for the p-value and we're comparing that estimate to the level of significance here. Okay, from there we've concluded our test and the interpretation here. You can leave it at the fail to reject part, but we can say, to combine it back to the story problem, there is not enough evidence to reject the claim that the true average weight of newborns is 7 pounds. I think we did pounds here, yeah. Yeah. This would be one way that you can make a conclusion based off of the story. The biggest thing that you want to know here is that you're failing to reject here. And how are we doing that? Based off of this chart. Okay. Disregard the next 3 slides. That was a copying error on my part. It's the same problem. You're not really losing anything here. And that concludes 8.2 content. Okay, so it's basically just a problem like that for all of these. Last but not least, we're going to do a checkout for the confidence interval reviews. Okay, so use the next slide to help you with these reviews. This is going to be some of the stuff that was in Module 4. And we're just doing that stuff because that one was also an asynchronous lecture, so I want y'all to get that content as well. So here, I'm going to have you pause the video, try these out on your own. We did similar problems to this last class, so again, this is just a cute little review. Okay, welcome back. What happens to the width of the confidence interval as we go from an 80% confidence to a 90% confidence? Okay, so as we go from an 80% to a 90%, if we look at the chart here, we're increasing our critical value. Okay, if we're increasing our critical value, we're increasing the margin of error, or the second part of the term for the confidence interval. Okay. When we're increasing that margin of error, we're adding and subtracting more and more from the population mean. This means that we're going to make the width wider. Okay. We also talked about it from that conceptual standpoint last class, that if you want to become more confident with something, you got to give yourself more wiggle room. That's like the conceptual interpretation of these numbers that we just talked about. Problem 2, what is the critical z-value for a 95% confidence interval for the mean? You want to go into the confidence interval critical values chart here, find 95%, and report the number that is given to you, which is 1.96. What 3 values impact the margin of error for a confidence interval about the mean? That's going to be these 3 here. Okay, so you got your critical z-value. Okay, this can also be related to your confidence level, which is denoted as your variable c, your population standard deviation, and your sample size. Okay, all 3 of these, 1, 2, 3, are going to be the things that affect your margin of error, which is the second term in your confidence interval equation. Okay, just for completeness sake, we're going to say we're going to write it out here, your critical z-value or your confidence level, your population standard deviation, and your sample size. All right, and that is your checkout. Thank you all again for being flexible with me, and I will see you all next week. Take care.